We just covered the basic definition of our three reactions that we'll be working with in strengths. Roller, pin, fixed. If you didn't watch that video and you don't remember any of this, I suggest you watch it. You have to understand this. So if we are going to look at a simple reaction from a simply supported beam or a simple cantilever, then we can let's just kind of make something up here and talk about the three type of loading. So we could have a uniform load, okay? And remember, it could also be linear, a function of x. We could have a point load, and we could have an applied moment, okay? So I have a pin and a roller. A pin, I could have, remember, an X and Y. We prevent translation. A roller, perpendicular. We're preventing translation. So let's just call this 10 pounds per foot. Let's call this 50 pounds. And let's call this 5-pound feet. That's my moment that's applied. And let's look at this. This is 10 feet. And this is 5 feet. Okay, so this might be what's given in the book. So the first step always is to draw a free body diagram. So I'm going to draw hand at A. I'm going to call this AY. I'm going to call this AX. I assume everything is positive, so up and to the right is positive. Then we might have BY. Okay, I'm going to go ahead and draw that rectangle of where that uniform load is sitting. And I know that we're just looking at the area under the curve. This is always the area under the curve. So that area is base times height because it is a rectangle. So I have 10 feet times 10 pounds per feet, and I get 100 pounds. So I've converted it from a pound per foot to a force load of 100 pounds. And I know that the centroid of a rectangle is smack in the middle. So I have 100 pounds and I have 5 feet and 5 feet. Okay. And then over here, I have 50 pounds. It's also at 5 feet. And this moment over here, it doesn't really matter where it is because it's a moment. So we have 5 pound-feet for our moment. Okay. So this would be an acceptable free body diagram. It has my unknown reactions. All of them that are possible are shown. It has simplified loads. It has all of the loads that are applied. So the first thing I'm going to do is I'm going to sum forces in the x direction. And I know the sum of the forces equals 0 because we're in statics. We are not equaling, well, technically we're equaling mass acceleration, but here in statics, our acceleration of the system is 0, hopefully. Okay, we're not looking at dynamic loading, so it's 0. So if I look in the x direction, I have AX. I don't have anything else, so AX must equal 0. So I can just box that in. So remember, we're going to have summation. The sum of our forces equals 0. So I have sum of our forces. I'm specifically telling you it's in the x direction. I'm also telling you my sign convention to the right is positive, and I know the sum of the forces equals 0. And so I have my rule on the left. Over here on the right is where I'm going to have my work. And I'm going to box my answer. Then, well, if I sum forces in the y direction, I will have 2 unknowns, and that is not very helpful. So let's do our sum of the moments, okay? And let's go about point A, okay? And I'm going to call right-hand rule positive equals 0. So again, my rule is I'm summing the moments specifically about point A, right-hand rule positive, it equals 0. So I'm going to stick my finger on A so I know where I'm going about. It's also nice because I know that my reactions at A are a distance away of 0, so they will not be causing a moment at A. So I'm going to come across here. Okay, I have negative 100 pounds times 5 feet. So the units of a moment are pounds feet. It's a force distance. Okay, then I have plus, that would be causing positive, by times 10 feet, okay, minus 5 pound-feet. We can see that's our applied moment. It's a negative rotation. Minus 50 pounds, and its vertical perpendicular distance is 5, 10 is 15 feet. I don't have anything else on here, and I know this mess has to equal 0. Okay, so I'm going to have 10 by equals 500 pound-feet, okay, plus 5 pound-feet, plus, let's use the calculator because I sometimes do weird math in my head. 50 times 15 is 750. So the reason these are all positive now is because using the sign convention about A, negative rotation, positive rotation, negative rotation, negative rotation. When I use my algebra correctly and I keep by isolated and move everything else to the 0 side, they become positive. So now I have that 10 by equals 750 plus 500 plus 5. So I get that equals 1255, and that's actually pound-feet. We're going to divide by 10 feet. So by equals 10 divided by, and I get 125.5. Okay, it's a positive number. That tells me that my assumption of by going up is the correct direction. Okay, I don't use a positive or negative with this. I do need to indicate the units, and I'm going to show direction. It is 125.5 pounds going up. Okay, when you give us an answer for a reaction, it needs to include the magnitude, the unit, and the direction. Because it came out positive, okay, I know it's actually going up. Had I gotten a negative value, then I would have said 125.5 pounds, and I would have shown it going down. Okay, so now that we have by, I can come back over here and I can sum forces in the y direction again. They have to equal 0. So again, I'm summing forces. This is my rule. I'm summing specifically the y component forces. My sign convention is up as positive. The sum of the forces equals 0. Okay, so here's my rule. Over here and over here, I'm going to show my work and I'm going to set it up identical. Okay, so I'm going to go left to right. So I have AY minus 100 plus 125.5, because I now know that this is 125.5. The moment does not affect a y component. It's a moment. Its units are pound-feet. The units over here are just going to be pounds. So then minus 50, and all of that has to equal 0. Okay? Please, 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 all of the forces equals 0. Otherwise, you may end up screwing up your sign convention if you try to just say AY equals and do it without looking. So I have AY equals 100 minus 125.5 plus 50. Okay, so I move that over, that over, that over. So AY equals 150 minus 125.5. So 150 plus, and I get that AY is 24.5 pounds. I got a positive value, so it's in the direction I assumed. AY equals 24.5 pounds going up. Okay, so the next one I will do will be a fixed end, where we have to also solve for that moment. Okay, when I have a pen and a roller, I can use the rule of finding the sum of my moments about a point equals 0. I do not show a moment on here because a pin and a roller cannot resist the rotation. Again, a pin is like a teeter-totter. If I sit on it, it's going to rotate. So this up here is the reactions that can actually happen. This down here are my 3 rules: summing forces X, summing moments about a point, and summing forces Y. Summing moments doesn't mean that a moment is occurring at that point. It's just the rule that we use for equilibrium.